Hello everyone, my name is Professor Mithyl Dave and welcome to MD's World of Concepts. So students, welcome to the mini series known as the periodic trends. In this video, I would be sharing the concept of ionization enthalpy, also known as ionization potential. I would be sharing its meaning, the factors which affect it, as well as the periodic trends. Would be also sharing some of the fun facts about it. So let's get started.
The following are the list of periodic trends. We have atomic radius, ionization enthalpy, electron gain enthalpy, electronegativity, metallic character, non-metallic character, and valency.
Ionization enthalpy. Ionization enthalpy is the minimum amount of energy required to remove the most loosely bound electron, the valence electron, of an isolated neutral gaseous atom to form a cation. Various ionization enthalpies. There are in total 3 ionization enthalpies. The most important out of them is the first ionization enthalpy. The energy required to remove the most loosely bound electron from the isolated gaseous atom is called as its first ionization enthalpy. The second and the third ionization enthalpy. The energies required to knock out the second and the third electrons are called the second and the third ionization energies. Well, the third ionization enthalpy is always the highest as compared to the second ionization enthalpy, and the second and the third are both higher than the first ionization enthalpy. The reason is because when the first electron is removed from the outermost orbit, the entire atom attains the nearest noble gas configuration and it undergoes stability. Now, it is always understood that the energy required to remove an electron from a stable atom will always be higher than an unstable atom. Hence, the energies are always higher in the second and the third ionization enthalpy compared to the first ionization enthalpy. Factors affecting ionization enthalpy. There are a total of 4 factors: the size of the atom, the screening effect, the nuclear charge, and the half-filled and completely filled orbitals. When it comes to the size of the atom, the larger the atomic size, smaller is the value of ionization enthalpy. In a larger atom, the outer electrons are far away from the nucleus and thus force of attraction with which they are attracted by the nucleus is less and hence can be easily removed. Therefore, the ionization enthalpy is inversely proportional to the atomic size. In case of screening effect, the higher the screening effect, the lesser is the value of ionization enthalpy, as the screening effect reduces the force of attraction towards nucleus and hence the outer electrons can be easily removed. Ionization enthalpy is inversely proportional to the screening effect. In case of nuclear charge, as the nuclear charge increases among atoms having same number of energy shells, the ionization enthalpy increases because the force of attraction towards nucleus increases. Therefore, ionization enthalpy is directly proportional to the nuclear charge. When it comes to half-filled or completely filled orbitals, the atoms having half-filled or completely filled orbitals are comparatively more stable, hence, more energy is required to remove the electrons from such atoms. The ionization enthalpy is rather higher than the expected value in case of such an atom. Therefore, ionization enthalpy is directly proportional to the stable electronic configuration, whether it is half-filled or completely filled orbitals. Now, let us learn about periodic trends of ionization enthalpy. When it comes to period, the ionization enthalpy increases as we go from left to right. Why is that so? Because due to decrease in atomic radius and due to increase in nuclear charge. Also, we had learned that the value of ionization enthalpy should always be positive, which is only observed in metals. When it comes to non-metals, they have the tendency to gain electrons rather than donating electrons. Hence, the energy and the charge decreases. When it comes to group, the ionization enthalpy decreases as we go from top to bottom. This is due to increase in atomic radius and decrease in nuclear charge. Also, as we all know that when we go from top to bottom, the tendency of an element goes on to become more having a metallic character than a non-metallic character, and therefore they have the tendency to donate electrons. Hence, the energy required to remove the electron from the outermost orbit decreases. So students, I hope you understood this concept. If yes, share this with your friends. Also, like this video, subscribe to my channel and leave your comments below. You can also check out other videos in the playlist. Also, you can find in the link above. Well, this is Professor Mithyl Dave signing off. Wishing you all the best for your exams. Bye-bye.